You've gotten a good overview of some important topics around EF Core's database providers. And this should be really useful for planning ahead, and you can dig further into the topics as needed. While different databases might have variations in their features, the work you do with EF Core to query and update data will almost always be the same, and the same as what you learned in this course. But the provider handles the specifics for its particular database. Interacting with a database that isn't even relational is such a great example of this with the Cosmos provider. However, with a non-relational database, you really need to be aware of how to model your classes and how to configure the provider. But when it comes to querying or modifying data, there's very little difference between what you saw in working with SQL Server. Transactions are an important part of database persistence. And now you know that not only does EF Core protect you with database transactions by default, you also have the possibility to take granular control of how that works. Then I ran through some FAQs about various ways to implement dynamic connection strings, connection pooling, which now you understand is controlled by the provider, DB context pooling that was designed for ASP.NET Core to help with very busy websites, and also how EF Core can help out when it's having a problem connecting to the database. In the next and final module, I'll give you a similar overview of ways to tap into EF Core's pipeline so that you're empowered enough to know what path to go down to solve particular problems. Here are resources and links for you related to the variety of topics that I covered in this module. I'm Julie Lerman, and thanks again for watching Entity Framework Course 6 Fundamentals. Hello, welcome back to Entity Framework Course 6 Fundamentals. I'm Julie Lerman, and you have reached the final module of this course. Woohoo! Congratulations! This module will give you some insight into common ways to tap into EF Core's pipeline. In other words, perform some tasks during EF Core's own internal workflow. I'll focus on the three most common ways to do this: overriding the DB context save changes method, taking advantage of some events that EF Core raises, and using a feature called interceptors, which allows you to intercept and modify information as it passes through the pipeline to the database and on the way back. I'll begin by overriding the save changes method, a capability that we've had since the very beginning of Entity Framework time and that transitioned into EF Core. The Save Changes method is a virtual method that you can override in your DB context class that gives you a chance to perform some tasks or data manipulation on details in the change tracker just before EF Core creates commands to send to the database. A feature of the change tracker that's key to overriding save changes is a method called entries. Change tracker entries returns all of the entity entries that the change tracker is maintaining. Recall that EF Core reads the details of those objects to construct the SQL sent to the database. So by having access to those, you can do things like manipulate values which will get picked up for the SQL commands. Here are a few high-level examples of how you can use save changes. You could do something with the entity entry data and then call the base save changes. And the base call is not one of those no operation methods I talked about before. Base save changes does perform the true save changes logic. And remember that save changes expects to return an int. So in this case, I'm also returning the result of that base call. In the second example, I'm grabbing the results of base save changes into a variable instead of just returning them. Then I'm performing some other logic that I might need after EF Core has finished its work. But after that, I still have to make sure my method is returning an int, so I'm returning that variable I captured. Interestingly, there are some unusual scenarios where you might want to perform your own logic and never even call base save changes, only call the base method conditionally. You can handle all of this in the override. Let's first take a look at the change tracker entries that you can access. I've got a solution that has the same classes and data model we've been working with throughout this course. However, now I've overridden the save changes method, and the only thing I'm doing here right now is accessing the entries. I'm not even calling base save changes yet, but I still have to return an integer in order for this to compile, so I'm returning 0. And what I'm doing here is just so that I can show you what's inside the entries. In my program class, I'm creating a new author with a new book and adding them to a pub context instance and calling save changes. With a breakpoint in the overridden method, here are the two entries returned by the entries method. But remember, these aren't my author and book objects, but the entity entry objects that are tracking my author and book. And they have a lot of details in them. Remember the debug view for the change tracker? Each entity entry has its own debug view as well. It also has a pointer back to the object that it's tracking. There's a collection of current values and original values. There's so much detail in here, and as tempting as it is for me because I find it fascinating, going any further will take us pretty far afield of the fundamentals. So I'll leave you to learn more about this at a later time. You don't have to retrieve all of the entries. You can use LINQ to do some fine-grained filtering. In fact, what I'm doing in this next line of code is using LINQ to get the first entry, but instead of returning the entry, I'm returning the actual entity object that it's pointing to. In the next clip, I'll show you an example of making those modifications to the entries in the Save Changes override. Here's an example of a common use for overriding save changes, setting the values of the shadow properties. I didn't spend a lot of time talking about shadow properties earlier, so I do want to make sure you do understand what they're for. They're a really, really cool feature that lets you store data in your database that's not relevant to your business logic. For example, you might want to keep track of when rows were created or updated, or even what user created or updated that row. This is really useful information when you're running auditing reports against the database. But if you had those properties in every single one of your classes and they have nothing to do with your business logic, they will just constantly be in the way. So this is a nice solution that the EF Core team came up with. Recall that shadow properties are known only by the DB context. This also means that you will need to use migrations to make sure that that new column is defined in the database. Because the shadow properties are not part of your classes, so you can't set their values the way you do for other properties. You have to do it through the DB context. When EF Core is about to save changes, it's just the right time to have the context set the values of the shadow properties. In this example, I'm defining a shadow property for the author type, and that goes into the onModelCreating method because it's describing the data model. Then I have a new method I've named updateAuditData, which iterates through any change tracker entries that point to author objects and sets the current value of its last updated property to the current date time. And then in my Save Changes override method, I call my updateAuditData method and then base save changes returning the results of that call, so that those values will become part of the SQL and get persisted into the database along with the other values. Although it's a bit more advanced, if you wanted every entity to have a last updated shadow property, that's also a possibility. EF Core raises events while it's working as well. There aren't very many of them, but they're pretty useful. There are 3 events related to save changes that you might use instead of overriding save changes. These are saving changes, which triggers before save changes is called internally, saved changes, which is raised after the internal call is complete, and save changes failed. There are also 2 change tracker events. Tracked, which is raised when the change tracker begins tracking any entity, and the other is when the state of an entity that's already being tracked is changed. You implement these events in your DB context class the same way as any other event in .NET. You need a method that executes the logic you want to occur, and you need to wire that up to the event. In this example, I'm separating my logic a bit more than that, so I can keep the handler method separate from the method with my logic. First is a method I've already created. We took advantage of it when we were overriding save changes, updateAuditData. I'm declaring a handler for the saving changes event, and notice that it's not the updateAuditData method that I just created, but a new one, saving changes handler. And then that saving changes handler method calls my updateAuditData method. Notice the signature of the handler method. Those parameters are required by the saving changes event. Let's take a look at this in code. Here's my pub context class, which already has that update audit data method. I've also added the handler in the pub context constructor. And now I will let Visual Studio's Quick Actions feature generate the saving changes handler method for me, because then I don't have to go look up the signature. I can never remember them. And once that method exists, I'll tell it to call update audit data. If you tap into the event args that come in with a handler, in this case it's the saving changes event args, you have access to properties specific to the event, which you can interact with if needed. But I don't have a need, so let's just see the update audit data in action. First, I'll comment out the save changes override method in pub context that I was just experimenting with, and I'll run the code again. The debugger has reached the update audit data method thanks to the handler, and it's now modifying the last updated shadow property of author. And here in the logs, when looking at the insert command for the author, you can see that last updated has its value in it. If you do have complicated rules around saving, you might find your code to be cleaner by separating the saving, saved, and saved failed logic into these events, instead of building up a big pile of logic and if statements within the save changes override method. One last notable point about the events is that you can use them to emit additional log information if you want, perhaps inject your own statements into the logs. And I find that the change tracker tracked and state changed methods provide some really interesting details. The next way to tap into EFCore's pipeline is through a feature called interceptors. If you used EF6, be aware that this feature is almost the same as it was back then, though it went missing in the first few versions of EFCore, but it's in here now. I like how interceptors are described in the docs. They enable interception, modification, and/or suppression of EFCore operations. This includes low-level database operations, such as executing a command, as well as higher-level operations, such as calls to save changes. I'll focus on the database operation interception, which I find the most interesting, to get a feel for how this feature works. The database operations you can intercept are commands, connections, and transactions. And for each, there are a number of points at which you can intrude on the operation. For example, just before EFCore is about to send the command to the database, giving you a chance to modify the command if you'd like. Another point is just after the database has executed the command. You can capture command failures as they're returned from the database, and just as EFCore is about to dispose the DB data reader that it created to capture any results, you can tap into that as well. For connections, you can access them just as they're being opened or closed, and if a connection fails. And those expose all kinds of details that you can interact with. And the transaction interceptor also exposes a number of points within its operation that you can view or manipulate. To use an interceptor, you first need to define an interceptor class, which inherits from one of those base interceptor classes. Then you implement the logic within any of those events that are exposed. Here's a class I've ingeniously named myInterceptor, which inherits from the DB command interceptor. I'm overriding its reader executing method, which gives me access to the command, its event data, and an interception result object. Notice that the method returns that result. If you're just modifying or doing work on the command, you do need to return that incoming result because it lets EFCore continue processing the command. But you can also return a new instance of interception result in a state such that it will cause the command to stop processing. Once the interceptor is defined, you need to register it with the DB context as part of the options builder configurations. And you do that with the add interceptors method. You can use add interceptors directly in your DB context class, or if you're using ASP.NET Core, in the add DB context method. You can register multiple interceptors at once as a list in the add interceptors parameter. And notice that I'm not just saying what type of interceptor, I'm creating a new instance of my interceptor. Also note that the interceptor has no impact on the data model, so it doesn't require migration.